Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is pent 4N1-ol. CH2 is equal to CH, CH2, CH2, CH2O, a terminal alkene with a hydroxyl group at the other end of a 5-carbon chain. Moving on to the next step. Br2 in H2O generates a bromonium ion intermediate at the double bond C1, C2 of the alkene. Moving on to the next step. The pendant OH group at C5 is perfectly positioned to form a 5-membered ring by attacking the bromonium ion intramolecularly. A 5-membered cyclic oxonium tetrahydrofuran ring, tetrahydrofuran is equal to THF, is highly favored by Baldwin's rules, 5-exotate. The oxygen attacks the more electrophilic, less hindered terminal carbon of the bromonium ion. And for the final step, the bromonium ion is attacked from the back face, anti-addition. The oxygen of the OH attacks the terminal carbon, C1, of the bromonium ion from the back, displacing Br in an SN2-like fashion. This gives anti-addition across the double bond, yielding a tetrahydrofuran ring with the CH to Br group at C2 of the ring and the ring oxygen at C1 with anti-trans stereochemistry between H and CH to Br at the ring junction carbon. Because the bromonium ion is achiral, symmetric plane considerations and forms on both faces of the alkene equally, two enantiomeric tetrahydrofuran products are obtained, one where CH to Br is on the wedge and H is on the dash, structure V, and one where CH to Br is on the dash and H is on the wedge, structure 6. These are the two enantiomers of 2-bromomethyl tetrahydrofuran formed via anticyclization. Options I and II would require water acting as the external nucleophile to give a bromohydrin. While possible intermolecularly, the intramolecular cyclization to a 5-membered ring is strongly preferred, faster intramolecular reaction. Options 3 and 4 represent open-chain bromohydrins with incorrect regiochemistry. The cyclic ether products, V and 6, are the major products. Therefore, the correct answer is C. Therefore, the correct answer is option C.